Yes, so this is second problem of our unseen problem solving challenge day one. So I'll read this problem. Okay, so we are given a binary search tree and we are giving a root. So yeah, before that I am starting a timer for that problem, and we need to determine if it is a valid binary search tree. So for a binary tree to be a valid binary search tree, its root node is always greater than its left element and smaller than its right element. So it is saying the same thing. The left subtree of a node contains only node with keys less than the node's key, and the right subtree of a node contains only node greater than the node's key. So both the left and right subtree must be also a binary search tree. So basically, what it's saying is, uh, so uh, if we have suppose that this tree, so at every node, if you will check all the nodes left to it will be smaller than the current node, and at the right side all the nodes will be greater than the nodes. So for example, if we consider the node 5, then in the left side we have 1 which is smaller than 5, and in the right side you can take any node. So this is not a valid binary tree because we are having 4 here. So yeah, this is, so all the nodes must be greater than the current node. Yeah, so we are given a constraint. The node value is very large, which is minus 2 to the power 31 to 2 to the power 31. Uh, Apart from it, I don't see any condition. So number of nodes may be 10 to the power 4. Yeah, so we cannot guess any approach from this input. So basically, we need to or recursively search for every node, the left side and the right side as well. And if it is a valid binary tree, then we will return it as. So the uh, the very intuitive approach coming in my mind is we'll check the first the base condition. If our root is null, root is null, yeah, that means we will return true. Yes, this is a binary tree. Else, if root is not null, so basically I'll have the two conditions here. If root is null, okay, so let me do this. So bool is left tree is BST. So I'll check the condition for the left tree. So I'll do is valid BST. Okay, so here I'll put one more condition. If root left is not equals to null, and then root is not equals to null, and then root is left not equals to null, and Okay, so instead of doing this, what I'll do is I'll make another function. So where I'll define the wool is valid vanity history. So because I'm thinking to take two variables here. One is tree. Why I have defined this function separately is because I'm thinking to have two values. One is max value, so like we will not have to check the condition for every combination such that such that node is greater than left node and the node value is less than right node. So we'll check the condition from this uh, this max value. Yeah. So I'll paste this condition here. If root node is null, yeah, and root node is null, else if root is not null, that means root has some value, and root value is greater than a max value. And similarly, I will have one more variable here, so which is min value, int min value, and max value. If root is greater than equals to max value, because the condition is strictly applied here, or root value is less than equals to min value, that means okay, so basically I have defined a criteria that every node must have a upper limit and a lower limit, and if that root value does not confined in that range, that means this is not a valid binary search tree, right? So in this case we will return false. Yeah. So now what I'll do is I'll return for both the conditions, like for every node to be a valid binary tree, it must, like its left tree must be valid, left tree must be a binary search tree, and right tree also need to be a binary search tree. So in this case it will check into left. So basically I'll show you how it will traverse it. So first it will go checking the left binary search tree. So for this example it will go to the left, and after one we can place one more condition here, but yeah, that will work, that is optional. If root, if the node has left and right both null, then it is a binary search tree. So this will be optional condition, because while like when it will check to the left, it will call recursively to the left, then again null value will also return true, again right value will also return true. So no need to explicitly mention this condition. So once it will return the left value, left. Okay, so in this also in this condition, the upper limit will be the 5. Yeah, so it will return true, and the right side it will go to the right side, right? So in the right side again 4 will have the recursive call to its right left side. So it's the node with value 3 has the upper limit of 4. Yeah, it's satisfy this condition, so it will return true. And in the right side the lower limit is 4 for the right, the nodes which are on the right side. So this also satisfied the condition, right? So this means this is completely a binary tree. Yeah. And now what it will do is it will check the condition. It will check. Now this call will come to the parent stack. So in parent stack call, it has already checked the left condition that upper limit is 5 and node 1 is less than 5. So it will return true from the left side. But in case of right side, the lower limit is 5, but we are having a node with value 4, so it will return false. But we have like put the end condition here, so overall it will return as a false and it will throw the false value. So this is pretty much explanation of this solution. So what I'll do is return is binary search tree to check for the left side first. Although you can check right side or left side, either uh, of the side, but I'll check to the left side, root left, and the root left will not have any constraint on minimum value. Any minimum value you can have, but it will have the condition on the right, on the maximum value, which will always be a root value. Yeah. And similarly, on the right side, I'll recursively call to the right side, root dot right again. Now we are having the condition on minimum value, which is the root value, and doesn't have any constraint on the uh, maximum value. Maximum value can be anything on the right side. Yeah, so that's perfect. Now it will return the yeah. So first, I'll call this function, and we will have to pass the values here. I'll pass the root node, and again, first the minimum value of the root node can be anything, ranging from int minimum to int. So maximum value can be int maximum, anything that, that will work. And again, while making the calls, it will update the values. So we don't need to worry about the int minimum and int maximum. Let's see if it runs. It is running. Let me submit this. Okay, all right. So we have passed around 77 test cases out of 85. Okay, so let me use this test case. So I'll see what what went wrong here. Uh, ha, 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 ha. Okay. Okay. So we are having a single node. Output is false, but it is expected to come as true, right? So if root is null, no, root is not null. Okay. If root is greater than max value or less than max value, how about it? I think it's a minimum, it's a maximum value, right? That's why it is throwing the error, because we have put the condition as if maximum value is equal, then we'll return false. Yeah. So okay. Okay. hmm I think in this case it should return the true. Wait, it will return the true. Uh, I'll try to submit it, and I'll take that a test case here. Mhm. Yeah, so in this case, it is returning true, but it is expected false because we cannot have the equal. Uh, mm, mm, yeah, but I think even if left side is okay, so this is our binary tree. So if even if left side is equals to node value or right side is equals to node value, then it should return the false. So our condition was correct. But the thing is, if the if we are having a single node, right? And if you are having a single node and it is going the int maximum value, then I think we need to define the criteria there. So I think I'll define the criteria here. If root is null, or I think that would work. Left is null and root right is null, then it will also return true value. Uh, 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 what does it mean? Mm, okay, so it will go to the left side, left, and the while going to the left side, root is not null, but it's the leaf node. So root left is null and root right is null. It will return true. Root true, but expected is false. Yeah, expected is false. Seems right. It will return true. But again, we are having the condition here. Cannot have the condition here because it will not check the. Uh, Actually, it cannot be the condition because suppose that it is a leaf node, but its value is not in the limits, right? So it can go beyond that. So I think this condition is perfectly fine, except the base condition that we are having a single node. So it will work perfectly, but here I'll define the criteria. If root is not null and then root left is null and then root right is null, that means this is a single node, right? So in this case we will return true. I think now it should pass all the test cases. Okay, my God. It really is very hard test cases. I don't know why it is. Okay, so I think it will pass all the test cases if I make one modification here. So I'll make long int, long int, and I'll see if this test case is passed. Not int minimum. So basically I have the int minimum plus 1 and the maximum plus 1, int minimum minus 1 and int minimum plus 1. So yes, so basically I'll make minus 2 to the power 31. 2 to the power 31 plus 1. Okay, so I think the integer range is 2 to the power 31. So I'll make the power 2 comma 32, or here I'll make the power 2 comma 32. Before that, let me print the value of power of root 2 comma 32. I don't know what is wrong with this. The output is false. Expected true. Why this is false? I don't know. The output will be 2 to the power minus 31 and 2 to the power 31. So I have taken 2 to the power 35. So basically I can make the 2 to the power 31 minus 1 and 2 to the power 31 minus 2 to the power 31. So basically I'll make the plus one, and here some output will be within this range. Now what I'll do is it will look for the yeah, now it will look for the this value minus, it is null, and this one minus. So this is min value. Okay, but I'm defining the wrong side here. Yes, and it is not greater than max value, greater than max value. Now it is less than max value, and it is again greater than the value. Yeah, I think the error was from the so I think it's better not to confuse with this value. You can make the 2 to the power 35 safely, so it will handle all the test cases without worrying about the input size and all. Yeah, perfect.